Hi, this is Prusa's new printer, the Mark IV, and these are actually shipping right now. As this video comes out, people will already be unpacking theirs. But I still had questions, and clearly so did you. Thankfully, the Prusa headquarters are only one charge stop away from me, so the best way for me to get answers was to just talk to the folks directly. Thankfully, they were cool with me coming over, and I've managed to grab Mikuláš Tusa and, of course, Joe Prusa for an interview, and I've managed to pack tons of information into this edit. There are timestamps on this entire video. They should show up in the player, but they're also in the description below, where you'll also find links to the Mark IV. All right.
Hello.
Thank you for finding the time. This must be a stressful time in your life.
Yeah, I'm not so sure if it was a good idea to plan the interviews for the day after release.
Let's I guess start out with the simple thing. What is like your one feature that you like the most about the Mark IV?
It is the load cell leveling.
So whole new hotend, whole new extruder, load cell, and no more pinda probe, the thing that set the Prusas apart.
Yeah, but what this does is that like the tip of the nozzle is searching for the subsurface of the plate. And if you are using anything induction, you know, even though our plates are super precise, there still might be a variation, especially with the PEI sticker ones. You know, there's a tolerance. There's a tolerance on the glue, on the PEI sheet itself, and if it stacks, you know, you might have like 20 microns difference in thickness of the coating.
Which usually works, but it's not perfect, and you can do it better. And this is universal now.
Exactly, and also you can, you know, change the nozzles, and if it's millimeter off, it's fine because it always searches by the nozzle tip. Yeah. So I think this is the ultimate.
You know, it's so nice to not worry about the first layer calibration ever again. We even had the defs deleted from the menu, like you couldn't adjust it at all. And we were like, okay, please put it back in some hidden menu. So if I do something really weird with the printer, so I have the ability to do so.
Yeah.
But otherwise, you just don't touch it. Nextruder, maybe, I guess. Huh? Nextruder, I guess.
Yes, that would be the next point. Yeah. So yeah, let's talk about that. It's an entirely different toolhead now, and in quite a few different ways. It's a new hotend, it's a new extruder, it's a new setup to connect to the mainboard. It's all new, right?
Yeah. So, I mean, I like this little thing where you can, the print fan is on a hinge, and you have the thumb screws where the whole hotend assembly slides out.
So it's not just the nozzle itself, but it's the hotend assembly with the heater block and all.
Yes.
Really easy to change. So no more V6 clamping geometry that you have to swivel in. I guess can you cold swap these? Yeah, you should be able to. You just pull out the filament first and then...
Yes. We forgot to do that before.
Yeah, we've tried to do that. Didn't work. But it's the same with Revo. It's compatible with the XL?
Yes.
Yeah?
Yes.
But what's the plan for you guys to make third-party or advanced nozzles for this setup that have this entire setup, this entire heat breaker?
The one we make different diameters already, 0.4, 0.6, 0.8, 0.25.
And it ships with a 0.4?
This ships with the 0.4, yes. The XL ships with the 0.6.
Okay, that makes sense.
Yeah, bigger printer, bigger nozzle.
I would have liked to see a 0.6.
You can just, you know, they won't be too expensive to buy the 0.6. But the one thing we have planned for sure is wear-resistant nozzles, like first party wear-resistant nozzle.
This is not a Revo. Why did you not go with the new big thing? Why is this still a V6?
So we've been working on this before the Revo was a thing, even in the E3D. But for me, it was extremely important that we do not break the compatibility, and I hope users will appreciate this. That, you know, if they have a collection of specialty nozzles, they can use them without any modification.
Yeah. You need the adapter? That's basically a new heat break now, but otherwise standard V6 nozzles fit. And I guess with the adapter, you could also put a volcano on here. You could do those sort of things.
Yeah.
And the adapter, because that's something some people have asked about. The adapter right now is available. You can.
It's available. We have like thousands of them in stock.
Yeah. Do you have a rough estimate of like how the performance of this hotend is, as far as like what the flow rate is like?
This one is quite similar to the stock V6 we had on Mark III, but.
Right.
But I must say we have a high flow version coming. I hope soon. Depends on E3D and the flow rates on that. It is unbelievable. But in the meantime,
I'm gonna have to believe that because there's no way I can check it now.
I can tell you afterwards. But again, you can use the printer with the adapter right away with CHD nozzle if you have it.
But of course, that eliminates the option to mount a different hotend, well, Revo doesn't really work with this because this isn't just a new hotend, but it's all integral. The heatsink is one with the load cell. It's all one big thing. So really, you are, I guess, limited to V6 style hot sides, as E3D would call it.
Yeah, but our mission is to make the printer the most reliable we can and the best performing we can. And we came up with this solution where we have integrated into one single aluminum part the extruder mounting, the load cell, the heatsink, and nozzle mounting. And there might be other ways to do it, but during the testing, we arrived at that this is the solution. If somebody wants to make aftermarket modifications.
Terry, I guess this isn't patented, right?
No.
So anyone could make nozzles for this.
Yeah.
But I guess what I can talk about with you is the entire input shaping situation. So as I understand it, input shaping is not done yet, so this is all sort of subject to change.
So with the input shaping, I would expect that we have alpha firmware out quite soon. I would say a month. You saw the demos, and you know that it's not polished with all the other parts of the printer, and we are not done with the optimization now. But I'm quite happy with the results. What is absolutely the best? All of our printers in the company are running on the same config, which we measured on
the same tuning of the input shaping.
I think this is possible because the printers are just so same. And mostly what input shaping is eliminating is the flex of the belts, and compared to CoreXWise, the length of the belts is just so much shorter on
the other hand,
i3 style.
On the other hand, though, you have the Z-rods, which are reinforced, so they're a bit thicker. I'm kind of worried that like the resonant frequency is different at the top where it's supported versus in the middle where it's free hanging. I don't know if that was an issue that you ran into in testing.
So far not. I'm not. As I stated, I don't think the whole speed race is the aim we should do, but at the accelerations, when I was testing it, the prints I showed, it's using 8,000 millimeters per second squared, which I think is perfect for this. I don't see such big differences when the printer is this way or that way. I mean, if we would try to be on the absolute edge, there might be bigger differences seen, but our printers are known for its reliability and basically start print and forget.
Yeah, you're leaving some headroom, so if stuff isn't perfect anymore, like it's still gonna work.
Yeah.
And I guess the other thing with input shaping is you've got a relatively heavy bed. It's lighter now. It has the skeletonized frame from the die casting.
Yeah.
So that I guess does limit how fast you can push it around. And input shaping, of course, does create some overhead. But you've got the new motors with the same drivers, so those work together, I guess, better.
We are using 400-step motors now.
Ooh, on all, I guess not on the Z-axis?
I don't think on the Z-axis, but they are specially tuned to produce as little VFAs as possible. So again, we were not aiming to be a speed demon, but more like precise, reliable workhorse. Yeah, and if we are to experiment, do the crazy things, I think the market is getting better now with parts, and we know what can be sourced and all this stuff. But this will be good, all reliable, and we will probably experiment in other machines.
One of the questions that came up was like, now with input shaping and with higher speeds and everything's like running faster, how much is there of a wear component in like bearings and belts and stuff just rattling loose? Is there a noticeable difference to slower Mark IIIs?
I think that there will always be some kind of wear difference when you go that much faster. Like the print times are about, I don't know, 1/3 compared to no input shaping on the Mark III, or like on the Mark IV with no input shaping.
Quick side note here for print times. I guess the Prusa estimates are still dead on.
Really spot on, yeah.
So I've gotten some questions like, how much faster is it really in practice? Just slice something in Prusa.
Yeah.
Put in your own printer, put in the Mark III, put in the Mark IV, just get your estimates, and they're usually pretty good.
We will have profiles, quality, speed, draft,
right,
as you're used to.
As with the older ones.
But maybe except this time there will be bigger differences. But yeah, there will be some difference in wear. From what we're seeing, it's not huge. And yeah, the things that would be a problem we tackled with like thicker zeroths, or having this closer to the actual axis, the extruder weight. So
I'm surprised how smooth this still
really
feels.
smooth.
My Mark IIIs feel like slapped out, or clapped out, or whatever the term is. Does it still have? Yeah, of course, it still has the press to move the Z-axis.
Yeah.
And that's actually one of the other things that we've briefly talked about before we started shooting this video, is the new interface. Because it now has a new mainboard on there, 32-bit, of course.
That's right.
It would be weird to bring out a printer today with no 32-bit board. But it's also got a new screen on there, and this is a touchscreen that is currently not being used. But your goal is like to basically, in regular use, you're not going to have to use the touchscreen at all.
Yeah.
The machine's going to do the stuff for you.
Ideally, the screen, the most useful moment it will have will be when you are starting a print, and it will show you nice thumbnail and then the list of the settings, that they are read from the file.
Okay.
And if you have the wrong nozzle or wrong filament, the printer will tell you.
Mark III does this already, I think.
Yeah, to a certain degree, everything that it can do, it does. But I think here it's like pushing it really a bit further, maybe even.
The bed is actually the same.
The bed is the same.
The PCB is the same, and the swappable print plates are the exact same. So you can use, even though it says Mark IV on here, you can use the ones from the Mark III, or Mark 3.5 and 3.9, which are now new as well. So these are the same, bed is the same, but it's mounted in a bit of a different way, so it doesn't flex as it expands.
Yeah, it has like these new mounts where it allows the bed to expand and stay even a bit flatter than before.
Which you could work around, I guess, if you just probed everything at temperature and just left it at that temperature.
Which we do, but it takes a while to stabilize and everything. So everything we can do hardware-wise to make the software compensation work better, we just try to do that. Really, a lot of the things evolved on the Mark IV over the time.
Yeah, so this is now a standard 10-to-1 planetary gearbox, essentially.
Yeah.
With a really tiny motor, so this is
pancake,
this is smaller than what's on Hemera almost, and it's only driven by one side now. The Filament doesn't have the dual drive, the Montec gears anymore.
But the drive gear is huge. It is absolutely massive. So as a result, you have several teeth engaging at once, which is especially nice for flexibles, for example, and stuff like that.
That was also one of the questions, like, how is performance with flexibles with this new heat break nozzle assembly? And you mentioned like it's really tightly constrained. This is like one continuous piece that is, I guess, crimped into the nozzle now.
There's nowhere for the flexible filament to go, so...
Yeah. I guess it does, that the longer this thing becomes, the more friction it builds up as it buckles and touches the sides, but I guess this is relatively well constrained.
Yeah,
that it's
exactly.
not really going to be
So
out.
we've been printing flexibles on it for a long time, and it's really nice for it. Yeah,
Flexible.
flexible.
Experience, but that's a rather hard one. Those are.
Yeah, you can go for the like, was it 40D that are available or stuff like that? The really squishy, rubbery ones.
Quick things about this toolhead still is it does have a filament sensor.
It does.
It does have a mechanical filament sensor, so the optical one is gone. There's no filament tracking, no jam detection anymore.
Okay. So it's,
I guess, right?
Like, okay, so as far as filament sensing goes, it's indirect. So there is a ball which gets pushed out of the way once you insert the filament. And there is a magnet holding this ball, and behind it is a Hall sensor. So in a nutshell, a Hall sensor sensing a magnet.
So it's
and a spring pushing. It sounds complicated, but really it's not that complicated.
Well, but it's a system with like no wear parts. It does have moving parts, like the ball gets pushed out of the way, but it's not like the switch wears out. Those switches have lifetimes of like 1,000,000 cycles. So
but exactly. There's the Hall sensor has no moving part, and the spring will last forever. On the topic of like sensing filament moving through, this is. Okay, I'm speculating here a little bit, but the load cell sensor like gives us so much data, and I think for now we are using it for the leveling, but we have the data throughout the whole time when we were printing even, and so what you're essentially getting is how much force is there against the nozzle at all times.
It can't just sense how much force is pushing up against the nozzle from the bed, but it can also sense the force from the extruder, right?
Yeah, exactly.
If that gets too high or it gets tricky because the motor is skipping, that's not currently implemented.
So no, that's not currently implemented, but the data is there, and I think it's only up, as you've seen with the Mark III, where over the years we are constantly getting more and more out of the same hardware with firmware updates. I see a huge potential for all the sensors that are on the Mark IV. We have the one thing about the Nextruder, there is a heat break thermistor. So there is, and you have customizable UI, by the way, on the screen. So you can put it in the footer right on the bottom of the screen. So at all times, this actually on the Mark IV, this is incorrectly not fully assembled. There is a filament guide now. So that this doesn't happen. But you can put for example, the heat break temperature into the footer. But anyway, you have another source of temperature reading from the printhead. So it's extra security feature. We have redundancy if one thermistor goes weird in exactly the way which doesn't sound suspicious to the firmware. You will see, for example, the temperature rising in the heat break. But that way we can also detect heat creep. We can, it's a really nice source of data, the load cell, heat break thermistor, normal thermistor, everything that's happening on the printhead.
Yeah, so that's all going into like this daughter board on the toolhead now, the love board you're calling it.
Yeah.
And that carries, I guess, the stepper driver, the drivers for the hotend thermistor circuits. I guess that all happens here, and then there's just some digital signal going to the main board.
So that's what's happening on the XL.
Okay.
So on the XL you have basically the processing loop, everything that's in regards to the toolhead, to the printhead, PID loop for keeping the temperature readings. On the XL, that's happening right on the printhead. Here it's more in line with what's happening on the Mark III. So you have the main board on the Mark III, and this is really just a breakout board with all the connectors, and it packs all the data in here as well and sends it to the motherboard, the X body, and that does all the processing and decisions and everything. But here, really, it's not that much processing that happens on the printhead on the Mark IV.
Yeah, and all that is running on a completely new board, the Prusa X body. 32-bit new connectors, so gone are just the pin-style connectors. These are new locking connectors on everything. The bed out and power in connectors are now massive slugs that are in here. It does still have all the temperature sensing internally, like monitoring the connectors and monitoring the stepper drivers and all that.
And we even doubled down on that. If I could highlight some features from it, I would probably, faster processor, it can run the screen and everything. But if I would highlight something, it would be the safety features. Because we have doubled, dual voltage monitoring of all the important branches. There's now also current measuring through all those connections that go into the parts that actually heat up. There are two MOSFETs for cutting off the power from the heatbed and the hot end. This is hardware protection. So if the firmware freezes in some really odd way that all the firmware protections won't work, the hardware will still catch it. So
this now also has Ethernet on board now, which I really appreciate. I don't like machines that require Wi-Fi because it's just such a hassle to set up. You plug this in and you can just access it. It does support Wi-Fi, and it does have a little ESP module, ESP SO1 or 1S.
Yeah.
That just plugs in the back, and it actually sticks out the back of the printer.
So it's not in the metal. This is actually a metal box now, not a printed one. So it's outside, so the signal is better.
Exactly. So that plugs in. That is included with the printer.
It is, yes.
And yeah, this is accessible with Prusa Connect now.
We really focused right now on the single printer users or people that have just maybe up to 3 or 4 printers. It should work fantastically for them. But there are also features for farms and companies that want to manage a fleet of Prusa printers. So it's been getting features for that, like teams, and you are assigning rights to user accounts that they can maybe monitor some of the printers, they can control some other printers. You have groups of printers.
Currently not implemented, not.
Some of it is implemented, some of it is even live. Some of it is hidden. So for example, if you are in the team, you see teams. If you are not currently in the team, the feature is hidden from you. And the user interface has gone through several changes, and it will go through several more, I'm sure.
Yeah. But you don't have to use the network functionality. You can still.
Yeah.
Well, still. I mean, this is new.
Yeah. Right. USB still
SD
new.
cards,
but yeah, if you hate sending data over cloud, just rip the Wi-Fi module out of the printer, and it will really be offline.
Yeah, so just to make it's actually automatically showing up the last.
Yeah, one-click print, right? You insert the flash drive, and it shows you the thumbnail of the last G-code you uploaded to the printer.
The interface that you've described, that's hosted on a Prusa server. I mean, I guess you can't without any cloud
you have
connection.
two things, right? You have the cloud service, Prusa Connect, which goes over the internet, and then you have the local thing, so Prusa Link. So that's the web server thing running on the printer itself. So you can also just send files over your local network without being connected to the internet at all.
But then, of course, you don't get those fleet management options,
and
teams, etc.
All the things like the statistics or history. We are using Grafana to read all the sensors, and we have to visualize the data from all the different sensors. And we will be opening that up to the users as well. So those hackers and people who really like to modify their printers and look at all the data, we will have a guide on how to run Grafana and visualize the data there. And the dashboard looks like a sci-fi screen, so I really like that.
But you're still using the TMC 2130 drivers, so this is the exact same ones that were in the Mark III.
That's true.
But you are using different motors. I guess performance-wise, there might be a bit better just to account for input shaping, but really that matchup between the motors and the drivers, especially with dynamic drivers, that makes a pretty big difference.
Yeah, we bought a lot of different motors. We tested them all, and what we were, one thing we focused on were the little vertical artifacts that you can see on some smooth surfaces. So that's the motors are the only difference between the 3.9 and the full 4 upgrade. And the motors make the difference in these fine vertical artifacts. It's up to the person spending the money to decide if this is worth it. I think the consensus here is go for the 3.9 because really you have to stare at the print from really close to see the difference. But if you care about it, if you really care about having the quality as good as possible, then these new motors will give you that.
So that's the very fine or vertical fine artifacts.
Yeah.
The other thing, I guess, bug 602.
Yeah.
With the extruder, which I guess was closed down to being, it's the two Bondtech gears not perfectly meshing at a certain distance, and then one moves and the other moves, and you get that pulsating filament flow. This now is a single-side drive. It only has the drive gear on one side and the regular bearing on the other. Well, I guess a slot. You can see it from the outside. It has a grooved bearing on the idler, so that issue, I guess, is gone, or mostly fixed.
Yeah, exactly. You can say it's gone. You can say it's mitigated to the point where you don't see it.
So you briefly mentioned upgrade from the Mark III to the Mark IV. I guess Mark II, you wouldn't need to do that intermediary step to Mark III. Maybe at that point it's not worth upgrading all the way to Mark IV, but there are several different options now. You've got the Mark III to 3.5, you've got the 3.9, and you've got the full Mark IV, which basically replaces most of the printer, I guess. So those are available, those are different steps. The 3.5 is just the board and the screen.
Yeah, which does add the input shaping. Kinematically, you will have everything the same, all the axes.
Right, so you'd be leaving the Mark III unchanged, you're just adding the new board, and you'll have a tune for that printer, I guess, then included in the 3.5 firmware. 3.9 is everything but the motors, so enclosures, I guess power supply is the same.
Extruder, most importantly. So 3.5, you don't get the fully automatic first layer. With 3.9, you do. It will basically be a 4 minus the motors.
Yeah. And then, of course, the 4, but I guess at that point, sell your Mark III and just get a brand new 4.
When we did this with the Mark II to Mark III, we initially didn't offer a full upgrade because we were like, you will be replacing like the majority of the parts.
Yeah.
But the community was very vocal about, that's fine, like some people don't have space for 2 printers, and they will still save some money compared to buying the full printer, and a lot of the people actually enjoy building.
Of course.
Yeah,
I prefer the kit options in your printers. So and the Mark IV is still available as a kit.
Yeah.
So you can build it. I would get that. Just versus the fully built one. The question, of course, that props up is like, what is going to happen to support of older printers, of the Mark III, the unupgraded ones, the Mark IIs, the 2.5s. They are still supported in Prusa Slicer, and that, of course, gives you many of the new features that make this printer tick. I guess this one with the older slices wouldn't be as great. Not that I'm implying that this one is great. I've not tested it yet, obviously. But what is your path forward with, like, how long is even this printer going to be supported? Is there a deadline?
There's no deadline. I hope our track record till now like speaks for itself, that we really try to support our older printers for as long as possible. And yeah, for even the upgrade paths, like we have now hundreds of thousands of Mark IIIs in the wild, and we really didn't want to leave them hanging and become outdated in a few years. So now with the, you have the upgrades, so you can get cost effective depending on what you want to upgrade. But yeah, with the firmware, I think we squeezed out pretty incredible things from the 8-bit board on the Mark III. And I bet anything that's still possible on the board that our devs will do. So yeah, we'll see what new things and little fine tunings we can do there.
This is now a shared software platform, I guess, for the entire Prusa line. Well, not for the SL1.
Yeah.
Yes, but Mini, Mark IV, and the XL all have the same processor. Basically,
the I-axis for the AFS farm, the like little Core XYs for the farm system. That's also the same Nextruder, and similar board. So yeah, it's shared, which makes sense. Why develop the same thing 5 times? We have our own PCB line, so we manufacture those in Prague right here. So yeah, we can do whatever we want, make some small changes to the board, and just put them in the printer.
Should we take a quick excursion to that SMT line? The other question, of course, is like, how does it fit into the market? Like, what's the justification of $1,200, well, $1,199 for the assembled Mark IV?
That's the price with VAT, right?
Well, us Germans, we think with VAT.
Yeah, but some people and some companies don't show prices with VAT. The thing is, we manufacture it here in Prague with good labor. We source the parts as locally as possible. We already gave out the Mark III S Plus product passport, so you can see how we make the machine responsibly and sustainably. We are continuing on with this. You also get our support with live people, 24/7 live chat. I would say ask people why they love their Mark IIIs. That is applied the same for Mark IV. The data shows that, especially when we did the survey for what the Mark III successor should do, it seems like people want the reliable workhorses, but the online creator community just wants, all the latest flashy things.
That's the hot stuff that you can get people excited for, but when it comes to really using a printer, maybe that excitement is misplaced, I guess.
Yeah, but you saw the machine running. You can have this besides you when you try to work and concentrate on something. Your girlfriend will not make you get it out the apartment.
And of course, with all the new frame, die cast, and thicker Z-rails, you're still using printed parts for pretty much everything around the printer. Why is that? Why not use what people like to call real manufacturing processes?
Okay, I think it should be quite mandatory for the 3D printer manufacturers to use their printers for their manufacturing, because 3D printing world would be much different now. This is such a great test of our machines and their reliability, because we log millions of print hours every week. And we know, thanks to this, we know how long the parts will survive. We can do optimization on that. We can be proactive. And price-wise, it is not that much of a difference compared to injection molded parts. We can be more creative here, and we can do more changes more often if we know that, okay, we now have 10,000 printers out and people have trouble assembling this part of the machine. We can change it just like that. And people can replace these parts very easily.
And these, I guess, have already been printed on Mark IVs.
This will be a mix of Mark IIIs, Mark IVs.
But they're in the farm, they're being used there for productive use.
Yeah.
And that's where you log the 1 million hours already.
But we will be switching the farm fully to Mark IVs. I think quite shortly with the high flow extruders. So
still to come.
Yeah. I think we will be able to double the throughput.
What am I going to get off of this table to get the MMU3 on here? So this is a slightly different MMU2, I guess. What I really want to know is, like, I guess the improvements that are in here people can look up, but the question for me is, like, how many people are using the MMU multi-material system on their machines? Is this something that like half of the users are getting and adding onto the machine?
You mean, okay,
experience from the previous ones?
Okay, yeah, actually surprising amount of people, like I would be making the number up.
So a substantial
amount of users do use the MMU. And the MMU3, I would say it's like a culmination of all the community mods as well, and everything, all the feedback we received on the MMU2. So it's really integrating a lot of the things that the users came up with and a lot of the things that our devs came up with, but the biggest difference is the way it talks to the user. So there is now full communication back and forth. Now it just tells you exactly what's happening on the screen, which is just convenient.
Okay. I guess that answers pretty much everything that I thought of and everything that you guys thought of. Thank you for your time. Best of luck with the rest of the launch.
Thank you.
Yeah, good luck editing.
Also, they have alpacas.